Welcome to Electron, and another really interesting part of water is that it's good at dissolving carbon dioxide. And that is a lot in the news these days, not per se in this particular respect, but let's take a look at what we mean by that. Well, the carbon dioxide molecule is a linear molecule like this, and since it has carbon in the middle and oxygen at the end, you can see that there's free electron pairs around the oxygen, so it is more positive at the center and more negative towards the ends. That allows water molecules then to form hydrogen bonds with the ends of the molecule. So carbon dioxide has an easier time getting into the water and getting dissolved by the water, therefore, than oxygen does, because oxygen doesn't have that property. It's a nonpolar molecule. And so once carbon dioxide gets into the water molecules will surround it and kind of electroinsulate it. So a large percentage of the carbon dioxide in the water will remain in the water like that. A small percentage of it will actually turn into carbonic acid, H2CO3. And then the carbonic acid, of course, in the aqueous solution of the oceans and the water, will then separate into the hydrogen ion and into the bicarbonate ion. And that, of course, causes the solution then to become more acidic by introducing more hydrogen ions into the solution. Now, what's also interesting is that if you place a glass of water, let's say on the kitchen counter, and let's say you put distilled water in there, and you measure the pH, and of course the pH of distilled water will be about 7, and you leave it around overnight, and you come back the next day, the pH will have dropped because the carbon dioxide in the air will have slowly dissolved into the water, lowering the pH, making it more acidic by having part of the CO2 that's been absorbed by the water turn into carbonic acid, and then of course making the solution more acidic. So that's a natural process. The amount of carbon dioxide that water can absorb and dissolve depends upon the temperature. At 0 degrees centigrade, water can hold 3.3 grams of carbon dioxide for every kilogram of water. For a kilogram of water is about 1 liter. And so for every 1 liter of water, there can be 3.3 grams of carbon dioxide in it at 0 degrees centigrade. But at 60 degrees centigrade, there's only room for 0.6 grams of carbon dioxide for every liter of water. So when the water gets colder, it can absorb more carbon dioxide. When the water gets warmer, it can't hold as much carbon dioxide and it goes back up into the atmosphere. So that causes, of course, if you think about the ocean right here, that causes more carbon dioxide to be dissolved by the water when it's cold, when the water temperature goes down, and that means that more carbon dioxide will be released by the oceans when the oceans are warm. So when the oceans are warm, a lot more carbon dioxide is returned back to the atmosphere. When the oceans are cold, a lot more carbon dioxide is absorbed by the ocean. So there's actually an interesting effect. If the climate gets warmer, more carbon dioxide will be driven into the atmosphere. When the climate gets colder, less carbon dioxide will be allowed in the atmosphere, and more will be drawn into the oceans. And it's very interesting when you think about the ice ages. During the ice ages, the carbon dioxide levels in the atmosphere were much lower than they are today because the oceans are much colder. When the oceans are much colder, they absorb a lot more carbon dioxide and pull a lot of that carbon dioxide out of the atmosphere. So that's a very interesting result of water. Again, water is the big carbon dioxide absorber. If it wasn't for the vast oceans in the world, there would be way more carbon dioxide in the atmosphere. But because of the oceans, the vast amount of carbon dioxide gets drawn into the oceans and dissolved and kept in solution like that by the hydrogen bonds of the water molecules. So, another great property of water. There you go, number 9.